the extraneous solutions. So for getting extraneous solutions, ladies and gentlemen, we talk about extraneous solutions for rational equations, and sometimes students, like, we will forget about them with logarithms. Always make sure you're testing your solutions, okay? Because again, remember what we're going to talk about in our last mistake is our domain is restricted for logarithms. Just like our domain is restricted for the rational function and our domain is restricted for the square root function, the domain of the logarithm is restricted to all real numbers. I'm sorry, to all positive numbers. So we have to make sure we might get some answers that are not going to fall within that domain, right? So therefore they can be labeled as extraneous. So let's go through an example so you can see. If I have log base 2 of x plus a log base 2 of x minus 7 is equal to 3. Again, I have the expansion of two logarithms with the same base as 2, so I can use my rules of logarithms to condense this down to one logarithm of x times x minus 7, and then is equal to 3. Now again, I see my same base 2, so what I'm going to do is exponentiate on both sides, right? You could rewrite this in exponential form, but we don't want to do that. You can use some parentheses to kind of contain what's in your argument. That's going to simplify left. Let's go ahead and distribute this. So therefore, that's going to be a x squared minus a 7x is going to equal to a 9. Now I recognize I have a quadratic. Now what do we know about quadratic equations? Quadratic equations, to solve, we want to set them equal to 0, quadratic formula, factoring, completing the square. But we also know we could have 0 real solutions, 2 real solutions, or we can have no real solutions. Or did I say 1? I don't know. We could have 1 too. 0, 1, or 2. So what I first thing I'm going to do is get this over to the same side. So I'll subtract a 9 on both sides. And I get an x squared minus 7x minus 9 is equal to 0. No. Oh, I forgot to change this problem. That's supposed to be an 8, I believe. Sorry about that. I didn't want to use completing the square. That would make this video so much more longer than it needs to be. So that was supposed to be an 8. I apologize. So now we want to see, well, can I factor this? Yeah, I can factor this. X minus 9 times an x plus 1 is equal to 0. Apply the zero product property. X minus 9 equals 0. X plus 1 equals 0. So therefore, x equals 9 and x equals a negative 1. So now what we need to do is these are the two solutions. But remember, ladies and gentlemen, these are the two solutions to this quadratic equation, right? If we just kind of forget about we even were dealing with logarithms, if you were just to solve this isolation quadratic equation, you would recognize, yeah, I have these two solutions. But now we need to go back to the original problem that how we even got in this mess. We need to make sure these two solutions are not only solutions to the quadratic, which we know, we want to make sure they satisfy our original equation. And the problem with x equals negative 1, it does not satisfy our original equation, because when I plug in negative 1 into the argument of my logarithm, I recognize that I cannot take the logarithm of a negative number, right? The logarithms, remember, are restricted for only positive numbers. So therefore, this is what we call an extraneous solution.